So in this video I am going to discuss cost equation or cost function, which is the application of linear equation or linear function. You see the equation of a straight line y equal to mx plus c. I said before this is a linear equation or linear function. So now I am saying that in application this equation is known as cost equation or cost function, where y is called total cost. Y represents total cost, and variable cost mx represents variable cost, or VC, and C is the fixed cost. However, in here M also indicates marginal cost or variable cost per unit. Marginal cost or variable cost per unit. And X is the number of units, or number of product, or number of commodity, number of units. So we can find a relation: total cost is equal variable cost plus fixed cost. And here the definition of marginal cost is what? The definition of marginal cost is the cost of making an additional copy, or cost of making an additional product. And C is the fixed cost, which is cost of making 0 units. If company somehow because of a strike is, let's say company will close for the next 3 months, still company need to pay some utility bill or salary of the employee, and these are the fixed cost. Let us try to understand cost equation by using a simple example. Let's say my apartment is here and I want to buy 3 marker from the nearest store, and the rickshaw rent from here is taka 10, and in order to come back again you need to pay 10 taka. So if I want to buy 3 marker and each marker has of cost taka 50, so the total cost y will be mx plus c, and here m is the variable cost per unit, which is taka 50, and I want to buy 3 marker, x equal to 3, plus fixed cost rickshaw rent taka 20. So the total cost will be 150 plus 20, which is taka 170. This is the total cost for 3 marker, and let us calculate total cost for 4 marker. That will be 50 into 4 plus 20, which is taka 220. And you see the marginal cost, I said cost of buying an additional copy. So this is the cost of 3 marker, this is the cost of 4 marker. So the cost of buy additional copy will be taka 220 minus taka 170, which is taka 50. This is the marginal cost. And again, let's say there is no marker in this store, so still I need to pay some money. The total cost will be m into x will be 0, plus rickshaw rent, that is taka 20. So this 20 will be the fixed cost, that is cost of buying 0 units. Now let us try to understand this problem, and let me read the problem first. Taxi fare from an airport to a nearby town is this $0.8 per mile driven. So this is your M. per mile, cost per mile, and this is the tools plus tools for one trip, that is your C. Let y represents the fare and x represents the number of mile driven on one trip. So write down the equation for y in terms of x, and we know equation for y in terms of x is y equal to mx plus c. Therefore, for this problem, our equation for y in terms of x will be this: m equal to 0.8 and c equal to 2. Of course, for one trip. And if you drive 17 miles on one trip, then the total cost will be 0.8 into 17 plus 2, which is $15.6. And let us read another example. It costs $2,500 to set up the machinery and presses needed to print and bind a paperback book. So this is the setup cost, which is fixed cost C. After setup, it costs $2 per book printed and bound. So this is your M. And X represents the number of books made, and Y the total cost making this number of books. A says write down the equation for Y in terms of X. So equation for Y in terms of X will be this: Y equal to 2x plus, because 2 is the M and C is this 2500. So this is your fixed cost. And B, state the slope of the line. So the slope of the line is 2. This is the slope of this line. And interpret this number. It means what is the interpretation of this number in business. And we know this 2 means marginal cost. So this 2 indicates marginal cost or cost of making an additional book. And in C, state the y-intercept of the line. So what is the y-intercept of the line? The y-intercept of the line is 2500. And interpret this number. What is the interpretation of this number? This number indicates fixed cost, which is cost of making 0 books. So the detailed solution of this problem you will see here in this sheet. So just have a look by yourself and try to understand the detailed solution. Although the solution I mentioned here is fine. So now let us try to understand problem 3. Let me read the problem. The total cost y of producing x units is a linear function. Records show that on one occasion 100 units were made at a total cost of $200, and on another occasion 150 units were made at a total cost of $275. Write the linear equation for the total cost in terms of the number of units. So let's say the total cost we know denoted by y, and in terms of the number of units, which is denoted by x. So you need to find a linear equation of y in terms of x, y equal to mx plus c in the first part, and in the second part, what is the total cost if 250 units were made. So it means when x equal to 250, what will be y? So here we are given two occasions. The first occasions is 100 units were made at a total cost of $200. So let us denote 100 units by x1 and total cost by y1. And similarly for the another occasion, let us denote 150 units by x2 and total cost by y2. So we have now 2 points. The first one is 100 and 200, and second one 150 and 275. Therefore we can calculate the linear relationship between x and y by using our direct formula, this one. and if you directly put your x1, x2, y1, y2 in this formula, then you will get the linear relationship, which will be this one. But let me solve this problem by using formula 1, which is y minus y1 is equal m into x minus x1. So in that case, first you need to calculate m, and m will be y2 minus y1 divided by x2 minus x1, and y2 means 275 and y1 means 200 divided by x2 150 minus x1 100. But if you consider y2 200, then x2 will be 200, and in that case y1 will be 275 and x1 will be 155. This is also okay, no problem. But let us calculate m for this case. So it will be 75 divided by 50, which is equal 3 by 2. So now let us use this one as x1, y1, and this is our m. So from this formula we can also calculate linear relationship between x and y. That will be y minus y1, which is 200, is equal 3 by 2 x minus x1, which is 100. And this implies y equal 3 by 2 x minus 3 by 2 into 100, which is 150, and from the left side 200 will be positive, and this implies y equal 3 by 2 x plus 50, which is our required linear relationship between x and y, and you can compare the result, which is same. Now the second part, what is the total cost? What is y if 250 units are made? So if you calculate, if you just put 250 for x, then you will get total cost y. 3 by 2 into 250 plus 50, which is equal, let us cancel this by 125, so it will be 375 plus 50, which is $425. So now let us try to understand another problem. Problem 4. A publisher asks a printer for quotations on the cost of printing 1000 units and 2000 units of books. The printer quotes this dollar for the 1000 copies. So let us denote this by y1 and this one by x1, like what we did in the previous problem. And similarly, this one will be y2 and this one will be x2. Assume that cost y is linearly related to x, the number of books printed. X denote the number of books printed. Then write the coordinates of the given points. So the coordinates of the given points will be x1, y1. When you need to write as coordinate, then of course you need to put two values. One is for x and another one is for y within first bracket. So the first coordinate will be 1000 and 4500. This is the first coordinate, and second coordinate will be 2000 comma 7500. This is the second coordinate. So from here, like what we did before in the previous problem, we can calculate m, which will be 3, and now picking one point, say you can consider first point or you can consider second point. So since we already denote this one by x1, y1, x1, y1, so it's better to consider the first point in this case. So if we use this formula, then it will be y minus y1, which is equal m into, and this is our m into x minus x1. So after simplification, you will get your cost equation. And the second part, third part of this question, which is what is the total cost of printing 2500 copies. So if you just replace x by 2500, then you will get total cost of printing 2500 copies, and that will be $9,000. Now let us try to understand another problem. Problem 5. As sales changes from 100 units to 400 units, so this is your x1 and this is your x2. Since both of them indicates the number of units, so 100 units will be x1 and 400 units will be x2, and the corresponding total expense will be y1 and y2. Assume that the given data establish the linear relationship between sales and selling expense as the two change, and assume that the relationship is linear. Find the equation of the linear relationship. So just what we did in the previous two problems, we need to use either formula 1 or formula 2. It's your choice which one is better for you. So but the first formula will be a simple one, I think, because the simplification in the second problem is a bit complex, so it's better to use the first formula. So in that case, we need to calculate m first, y2 minus y1 divided by x2 minus x1. That will be y2 150 and y1 75, and x2 in the denominator 400 minus 100. So we have 75 divided by 300, which you can convert in the decimal form, or you can put it in this way. In that case, you can simplify this one, which will be 3 by 12, or better put it in this way. So the required linear relationship between sales and selling expense is of the following form, by using formula 1, y minus y1 m into x minus x1. So which implies y minus y1 is 75 and x1 100, and this is the slope. So that is the answer. And similarly, you can also check another problem, which is again like the problem 5. As the number of units manufactured increases from 100 to 200, so this one will be your x1 and this one will be your x2, and manufacturing cost increases from $350 to $650. So this one will be your y1 and this one will be y2. Assume that the given data establish the relationship between cost and number of units made, and assume that the relationship is linear. Find the equation of the relationship. So like exactly what you did in the previous problem, you can solve this one by yourself. Either you can use formula 1 or formula 2. So first, in the same way, you can calculate m equal y2 minus y1 divided by x2 minus x1. That will be 3, and now put the value of x1, which is 100, and y1 350. So y minus y1 equal m into x minus x1, which is equal y equal 3x minus 300 plus 350 from the left side. So the final answer will be, final linear relationship between x and y will be y equal to 3x plus 50. This is the answer of this problem. So now let us try to understand problem 7, and this is our last problem in this lecture. Let me read it. If taxi fare y is 50 cents plus 20 cents per quarter mile, write the equation relating fare to number of miles traveled, which is denoted by m. So first let us denote the equation relating fare. Fare let us denote by y, and number of miles traveled let us denote by x. Then we will replace this x by m at the end. And here taxi fare y is this cents, which is your c, plus 20 cents per quarter mile, which will be your m. But this 20 cents is per quarter mile, so you need to convert it per mile, and that will be what? That will be per quarter mile your amount is 20 cents. So per mile it will be 20, 20, 20 and 20, it will be 80 cents. So your m will be 80 cents, and 80 cents is equal to $0.8. $0.8, because $1 is equal 100 cents. $1 is equal 100 cents. So you need to divide 80 cents by 100, that will be $0.8. And again C is equal 50 cents. C equal 50 cents. So if you convert 50 into dollar, it will be 50 by $100, which will be $0.5. Now your equation for y in terms of x will be y equal mx plus c. So your answer will be y equal to m 0.8x plus c, which is 0.5. But the number of miles traveled in this question, they said we need to denote the number of miles traveled by m. But in this result, we denote the number of miles traveled by x. So according to this question, your answer will be y equal to 0.8 m plus 0.5. However, if your question ends at here, that do not denote m, number of miles traveled by m, then in that case this one will be your answer. But according to this question, this is your answer. And that's all in this lecture, and in our next lecture I will discuss break-even analysis. So thank you for listening.